biology. We're talking about section 13-3, which is called nutrient cycles. And some of this you've probably seen before. There's some vocabulary. Now, the key word here is cycles. Cycles means it's going around in a circle. Now, notice, this is very different from the flow of energy through the system. Through the ecosystem. Now remember, when I started off, and I said it was important, I said basically an organism needs two things. It needs a source of energy, and it needs nutrients. Okay? Ultimately, all energy comes from the sun. It goes to the earth. It goes to the plant. Remember, this is what I showed you. It goes to the cow. It goes to the person. And then it gets lost. It's actually one way. Energy is not recycled. Sorry. Energy is not recycled. All right? Nutrients are recycled. And it's a darn good thing because there's basically no new nutrients coming into the earth from outside. Nutrients are recycled. So here's the idea. They come from the earth. I showed you that in the last one. Nutrients come from the earth, ultimately, whereas energy comes from the sun. So you see this kind of, we're setting up these two categories. Energy comes from the sun. It flows through the earth system. It's ultimately lost. If you're wondering how it's lost from the earth, it's actually ultimately lost as heat. Eventually, all the energy that comes into the earth is either stored as chemicals or it's lost as heat to outer space. Right now, you guys are all giving off heat. That heat is energy that's gone forever. There's nothing out there in the ecosystem that's collecting that heat and using it. It's just being lost. And then it eventually radiates out into outer space, into the atmosphere, and then from the atmosphere into outer space eventually. Now, fortunately, because nutrients come from the earth, if nutrients were lost to outer space, that would be a bad thing, because what would happen is the earth would eventually run out of them. You follow me? If nutrients were coming from the earth and being lost to space, then what would happen is eventually the earth would run out of nutrients. So let's talk about these nutrient cycles. This is the recycling process that happens in nature. I'm not talking about like, when you recycle stuff, although it's the same thing. When you recycle metals, or if you have a compost pile that you use to kind of recycle the organic materials that you use, foods and stuff like that. But I'm talking about in nature. You only need to know about three. Really, mainly two, but I'll mention three. First is water. And this is in your book on page 293. Now, what does a cycle mean? It means it basically goes around in a circle. So we'll have some land here, and then we'll have some water. Very basically, we have... Am I going too fast?
Yes.
Okay, I'll slow down a little bit. We have evaporation. Now, by the way, evaporation can also happen from the soil. It also happens through plants, and in that case it's called evapotranspiration, when the water actually goes through the plants, but don't worry about that term. So we can lose water from plants also. Then when you form clouds, that is called condensation. That's cloud formation. Did you know that clouds aren't actually gaseous water? They're actually little drops of water, of liquid water. When it's foggy out and you see those little specks in the air when there's fog, and you take your flashlight out and you do like the lightsaber thing in the fog, that's because they're little specks of liquid. Because fog is just a cloud on the ground, right? Fog's a cloud on the ground. If you were up in the clouds, it would just look foggy. So like when you're on an airplane, you fly through the clouds, you see fog. So that's condensation. Then what do we have? Then we have the one that returns it down. So to have a cycle, we can't just have up, we have to have down too. It has to go around and around. What's that called? Precipitation, right. All right, now sometimes precipitation falls down to the ocean, but sometimes precipitation falls on the ground. Then we have, in the soil, we have percolation. When the soil's going down through the soil. Infiltration, when it goes through the surface. You don't have to know all these terms. And then the last one I want to show you is groundwater flow. And actually, I should say another one is runoff, which would include things like rivers and streams and groundwater flow. So we're not going to spend a lot of time on this, and it's pretty straightforward. Water evaporates, it condenses into clouds, it precipitates and falls down to the ground as rain, and then it goes back. It either goes down into the soil or into streams and rivers where it can run off of the ground, and it ends up back in the water bodies, in the rivers, in the lakes, in the ocean, where it evaporates again. And just remember that evaporation also happens from the soil. That's why your lawn gets dry in the summer and stuff like that, because it's drying out from the soil. Here's the thing, folks. They are not making any more water. They're not making any more water. All the water we've got on Earth is all the water we've got. Now, if you want, you could also show glaciers up here. What's that? That's supposed to be a glacier. This is a mountain. So maybe you've got snow, and so some of the water could be frozen too. But the basic idea is they're not making any more water. This thing just goes around and around and around. One of the nice things about this is that when the water evaporates, it's pure water. So it's kind of a cleansing process that goes on here over time. When the water evaporates, it's pure water. That's why the water's not just getting dirtier and dirtier and dirtier over the millions of years of Earth history. Because every time it evaporates as pure water and comes down as clean water in the rainfall. But that's what we mean by a cycle. So I'm just going to put this in quotes here. They're not making any more water. Who's they? Whoever you want it to be. Nobody is making any more water. There was a time toward the beginning of the Earth when all this water came squirting up out of the volcanoes. That's where it came from, right? Or maybe it came from comets that were made of ice and they struck the Earth, and maybe that's where the water came from. But we're hoping that no big comets are hitting the Earth anymore. And so they're not making any more water. It's just cycling around and around and around. All right, enough of that. How about carbon? Carbon cycle is very important because it's related to global warming, for one thing. So let's draw a picture of the carbon cycle. Now, the pictures in your book are nice, but they don't really show it as a cycle. They just kind of show different arrows and stuff like that. So let's do the same thing here. All right, I'm going to show you a picture of a carbon cycle. And this time we need maybe a tree here. All right. Now, where's the carbon? There's carbon in the atmosphere. Okay, by the way, there's water vapor in the atmosphere too, but there's CO2 in the atmosphere. Now, there's actually not a lot. We're talking about 0.01%. So that is not a lot. When you hear people talk about the greenhouse effect and global warming, sometimes you get the impression that the atmosphere is like chock full of CO2. It's not. It's still only about 0.01%. There's CO2 in the water. There's carbon in plants. There's carbon in animals. Yeah, we count as animals. We're basically, we move around like animals. We're not plants, right? So, must be animals. Okay, anyway. Now, no, I would not say we are just animals. I wouldn't use the word just. But anyway, there's carbon in plants, carbon in animals. Now, what else do we have? We have dead plants. There's carbon in dead plants. Now, this is important because, like, if you go out in the forest, folks, there's actually a heck of a lot of carbon on the ground in the forest, right? So it's not something to ignore. The dead stuff you can't ignore. You go out in the forest, there might be 4 or 5 inches of dead leaves and stuff on the surface. That's a lot of carbon. There's carbon in dead animals.
What is that?
This is a dead raccoon.
That does not look like a dead raccoon.
There's a carbon in the dead raccoon. Okay? So there's carbon in animals. There's carbon in dead animals, obviously. Your tissues a lot of them are carbon. Proteins have carbons. Remember, carbohydrates, right? There's carbon in the soil. There's carbon in the soil. That's what makes it brown. What makes the soil dark brown, like really the color of dirt, that is carbon. When you see that brown color, the dark brown color of soil, folks, that is microscopic remains of dead animals and plants. It's dead stuff mixed in with sand. Soil, listen, soil is dead stuff mixed with rotten rocks. All right? That's what soil is. That's what dirt is. It's dead stuff mixed with rotten rocks. Dead things. Dead things. Dead plants, dead animals, dead insects. Okay, now, what else? There's CO2 in the oceans, which is important when we talk about global warming. After this, this is actually very important because the oceans are huge. And because they dissolve so much CO2, they are one of the biggest places where carbon is found on the Earth. And one of the wild things about oceans is as their temperature changes, they either absorb or release CO2. So it has a huge kind of impact on global warming. And then finally, there's carbon in rocks.
No, really.
In limestone. Not in all rocks. These kinds of rocks don't have any carbon in them. Okay, the rocks we have around here don't have carbon. But limestone, in some parts of the country, the rocks are limestone and they contain a lot of carbon. And they were formed under the ocean. And by the way, they're formed by little microscopic organisms that use the carbon dioxide in the water to make their shells. That's what seashells are made of. Did you know that? Seashells are calcium carbonate. What's that? Turtle shells, that's a good question. What are turtle shells made of? I don't know. Okay, folks. Give me 5 more minutes. Maybe not 5. Where do these things flow? Because I haven't drawn any arrows. I've taken a little bit different approach here. I'm showing you where the carbon is. How does carbon get in the atmosphere?
You burned it.
Okay. Respiration. Respiration. Okay. Carbon dioxide gets into the atmosphere through respiration. It gets into the atmosphere through combustion. So let's say I have a fire here. I'm going to make a fire.
I knew it.
Combustion. Okay. Respiration, combustion. We have respiration actually occurs from the soil also. Respiration of soil organisms. Okay. And then, of course, CO2 can either go into or come out of the atmosphere from the water. And we'll talk about that a little bit more when we get to global warming. So when you're breathing out, CO2 is going into the air. But look at this. I don't have a cycle yet, do I? And this is going to get messy, sorry. I don't have a cycle yet because I only have arrows going one way. Did you notice that?
You have yours.
Well, but this arrow is pointing.
Yeah, one's going back into the water.
Right. So I have one, but there's a big time cycle arrow that goes backwards like this. What am I going to call this? CO2 going into a plant and becoming part of the plant. Photosynthesis. Right. That's the big one for going from carbon dioxide in the air into plants. And then, of course, when we eat plants, it goes into us. And then when we die, it makes its way down into the soil. And then it ends up going through the soil organisms back up into the atmosphere. This is kind of messy. I think what I'll do is I will find a nice picture of the cycle online and I'll post it on the thing. Because even your book's kind of similar to my picture. It's just kind of arrows here and there. I want to make a nicer cycle picture for you of this. You know what's interesting though? It actually looks a lot like the thing that we used to draw for when we were talking about respiration and photosynthesis and how it was a cycle, right? CO2 in air, photosynthesis. It becomes part of plants, right? Then we have, we could draw it something like this. Plants, some of the plants go into animals. Here, let's draw it like this. This isn't too bad. This will be respiration. Putting it back up into the air. See how that works? So this is the main part of the carbon cycle. However, and this is where global warming comes in. A long time ago, and I didn't draw it on this picture, back before the dinosaurs, the Earth was a big tropical swamp. And basically all those swamps got buried and they got turned into coal. So in some places, there's coal and oil under the ground. And if we pump that coal and oil out of the ground and burn it, we're going to be adding more CO2 into the air. So coal and oil. So notice how I'm drawing this kind of separately. See that? Now, the problem with fossil fuels, as we'll see with global warming, is that all that coal and oil was formed a long, long time ago, like 100 million years ago or older. And it's basically been stored. So we're kind of adding to the cycle. See, look, if this is all that's happening, then the amount of CO2 in the air stays the same all the time because it's just a cycle. It's a recycling process. It stays the same. But when we burn coal and oil, it's not really part of the cycle anymore. So we're just adding stuff to the cycle. We're adding more CO2, and that's why the CO2 content of the air goes up. And what's bad about that? Who knows? Well, not right away. It's different than ozone layer. Ozone layer is the one that protects us from the UV light. That's what like aerosols can damage. CFCs, aerosols can damage the ozone layer. CO2 does what? Most of them have ozone-friendly propellants now, so it's not usually a problem anymore. What does CO2 do, though?
Slowly kills you.
CO2 is really good at absorbing heat. So all that heat coming off the Earth gets absorbed by the atmosphere, and the whole Earth warms up.
Is that what CO2 is called? Like CO2 for like
That's different. That has to do with the depressurizing, like when you let it out. It has to do with the depressurization.
Yeah, 'cause it gets really.
Yeah, it gets really cold. In the atmosphere, it tends to retain heat, which makes the whole Earth warmer. Some people say that's why we're having all these nasty storms and stuff these days. It's because there's more energy in the atmosphere because the CO2 is soaking it all up. I think it might be true.
But how is that if we only have 0.01%?
That's a good question. A little bit goes a long way. CO2 is really good at absorbing stuff. Now, by the way, our CO2 content is still a lot less than it was during the time of the dinosaurs. You won't hear that a lot of times. Our CO2 levels are still much lower than the dinosaurs, but here's the thing. When the dinosaurs were around, there were no ice caps. Everything was tropical.
The whole world is tropical.
Basically, the whole world was tropical.
That's big.
So you're talking about when they go up. Now, a lot of people say that. So a lot of people say, what's the problem with global warming? Because I wouldn't mind if it was like Aruba here in Connecticut, right? The problem is, there's a couple problems. One is, if the ice caps melt, the sea level rises, big time. The other problem is that if this happens really fast, then the species may not be able to adjust. Things like agriculture and ecosystems will not be able to adjust fast enough. So that's all I'm going to say for now. We'll go back to